Okay, we're looking at some double angle formulas today. These formulas are given to you in your formula packet. So the first one deals with the sine of a double angle. The second one, the cosine of a double angle. Notice with the cosine one, they give you three different formulas. They write them out horizontally, so you have to make sure you can see that there really are three separate ones there. Let's look at some examples. In the first case, we're told that the sine of x is 3 over 4, and that our angle x is between 0 and 90. That's telling us that we're really in the first quadrant, where all of our trig functions are positive. We're looking to find the exact values of the following, and we're going to do this without actually finding our angle. Okay? So, if we're looking to find the cosine of x, this is not a double angle, so we're not going to use those formulas just yet. Alright, but I'm going to show you a couple different ways of getting this. So first, let's draw ourselves a right triangle in the first quadrant. X is our acute angle. If we're told that the sine is 3 over 4, you know that sine is opposite over the hypotenuse. Alright, so we can mark those sides in our triangle. Well, if we're going to find the cosine of x, we need the adjacent over the hypotenuse. So I'm going to call this adjacent side A. So we're going to need Pythagorean theorem here to find that missing side. So let's go ahead and do that. You don't need to show all the steps. We know we're going to have 9 equals 16. Subtract over that 9. A squared would equal your 7, and then A would be the square root of 7. Okay? So this adjacent side is root 7. So that makes the cosine of our angle the square root of 7 over 4. Okay? So again, we haven't actually found the angle. We just know that the cosine of that angle, whatever it is the square root of 7 over 4. Another way of looking at this, we talked about in class how we have another formula, Pythagorean identity, sine squared of x plus cosine squared of x equals 1. Okay, remember, it's the entire quantity squared, not just the angle. So we know that the sine of x is 3 over 4, so I can replace sine of x with 3 over 4. A common mistake, by the way, is people want to write the sine of 3 over 4. Well, the sine is gone. The sine of x is 3/4. Okay, so that's squared, and then we have plus cosine of x squared equals 1. Well, we could now solve this equation for the cosine of x. So I'm going to go over here. So the cosine of x, alright, this quantity squared would equal 1 minus, so I'm going to subtract over this 3/4 squared. Well, when we square that, we get 9 over 16. You're going to square each part. Okay, so now our 1 is 16 over 16 minus that, so I'm getting a common denominator. So 7 over 16. Now remember, that's the cosine of x squared. So if I just want the cosine of x, I'm going to square root that. Well, if I square root 7 over 16, I get radical 7 over 4. If I square root my top and my bottom. Notice that matches what I have doing it the other way. So you don't have to do it both ways. I'm just giving you another method to find your cosine of x. Alright, next problem here, we're asked to find the sine of 2x. So if we use our identity from up above, the sine of 2x is equal to 2 sine of theta, I'll replace theta with x, times the cosine of x. Well, we've already found these parts. Okay, we are told that the sine is 3 over 4, and the cosine is radical 7 over 4. So you're just going to multiply straight across. Think of this 2 as really being over 1. So we're going to have 6 radical 7 all over 16. Let's reduce this, turn it into 3 radical 7 over 8. Okay, so that would be our simplified answer. For the cosine one, again, we have 3 different formulas we could use. And you're going to choose your formula based on what you know. Well, since we know both the sine and now the cosine, we could use any one of these 3. So I'm going to pick the last one here. I'm going to use the 1 minus 2 sine squared of theta. So that really means the sine of x, this entire quantity, squared. So, and again, I'm going to pick that one because I'd rather deal with 3/4 than my previous answer, which had a radical in it. Just makes life a little bit easier. So we're going to substitute in. I'm replacing my sine of x with just 3/4. Okay, and then just remember your order of operations. I'm going to have to first square this, so that's 9/16. Alright, and then 1 minus. People always mess up on this next step. To do 2 times this fraction, think of it as 2/1, so it just becomes 18/16. We're only doubling the numerator, not the denominator. So 1 is the same as 16/16. I'm getting a common denominator here. So this would be -2/16, which simplifies to -1/8. And lastly, my tangent here. My tangent of 2x, well, I don't have a formula up above for that. Recall, though, this is in your formula sheet. Let's write this down again. Tangent of theta is equal to the sine of theta over the cosine of theta. Well, I've already found my sine and cosine. So if it's the tangent of 2x, well, it's the same idea, except now it would be the sine of 2x over the cosine of 2x. Okay, so I found the sine of 2x from up above. Right here we said it was 3/7/8. And then my cosine of 2x, I found that to be -1/8. Well, each of these fractions are being divided by 8, so we can get rid of those 8's. Alright, so that -1 on the bottom, I'm going to just bring that up and write it as -3/7. That's what we'd have remaining for our final answer. Okay, and in our next example here, again, we're given an expression for sine, and we're told our angle x is between 180 and 270 degrees. Well, this really tells us that we are in the third quadrant. Okay, we want to find the exact values of the following. Well, first off, the sine of 2x. We know our formula tells us this is equal to 2 times the sine of x times the cosine of x. So I know my sine is -1/8, but I don't know my cosine. So off to the side, I need to find the cosine of my angle. So to do this, I suggest drawing yourself a right triangle in the third quadrant. Okay, and this is going to be our reference angle, which we'll call x. Well, we know that the sine is 1/8. Now the negative is just because if we do our ASTC, only tangent is positive down there. When it comes to labeling the sides of my triangle, I'm not going to label anything in negative. So sine is opposite. So this is 1 over hypotenuse, so this is 8. Okay, so we need to find this missing leg, which we'll call A, if we're going to find our cosine. So we need Pythagorean theorem. A squared plus 1 squared equals 8 squared. So our A is going to end up giving us 64 minus 1, so that's square root of 63. Okay, so my adjacent side is the square root of 63. So that suggests that my cosine of my angle x would be the square root of 63/8. But don't forget, cosine is also negative down there, so we're going to make that negative. So I'm going to go back over here and write in -√63/8. So let's multiply across. All right, we're going to have that negative times a negative, so that's just going to be a positive. 2 times the square root of 63 all over 8 times 8, which is 64. Let's reduce this. I can divide 2 into that 64, so my simplified answer would be the square root of 63/32. Next one here, cosine of 2x. Again, we have 3 choices that we could use since we know sine and cosine. Okay, so I would rather use the one that doesn't have a radical in it. So I'm going to use the sine one, which again from up above we said this is 1 minus 2 times the sine of x quantity squared. So we're going to substitute in for sine of x. We're told in the problem it's -1/8. All right, and then we're going to square that. So again, order of operations tells us we have to square this first. When you square this, we get 1 over 64. Okay, and then from there, we're going to have to multiply this fraction by 2. All right, think of this as 2 over 1, so this is going to give us 2 over 64. Okay, we're not multiplying top and bottom by 2, just the top. So from there, 1 is 64 over 64. So we're just going to get a common denominator. So 62 over 64, which becomes 31 over 32. Okay, for our simplified answer. And you could have used the other formulas. You would have gotten the same thing in the end. Tangent of 2x, like we said earlier, this is the same as the sine of 2x over the cosine of 2x. So the sine of 2x from up above, that was radical 63 over 32. And then my cosine of 2x, we said, is 31 over 32. These are each divided by 32. So we can cross those out, and we're left with the square root of 63 over 31. And the last thing here, the sine of 4x. Well, this is really a sine of a double angle disguised. If we look back up above here, our formula for the sine of a double angle, I want you to circle your 2 theta, and then your theta, and your theta. This does not literally have to always be 2 theta. It just simply has to be double whatever angle we have inside there. So if this on the outside were 6 theta, these would each have to be 3 theta. Okay? It just has to be double. So right here, the sine of 4x, this is really 2 times the sine of 2x times the cosine of 2x. So again, focus on, circle these angles, please. Notice this 4x angle is this 2x doubled. Okay? So seeing that is really the hardest part. Once you have that down, from there we're just going to plug in. The sine of 2x we found up above. It's radical 63 over 32. And the cosine of 2x we found from up above is 31 over 32. Okay, and I can reduce this a little bit. Alright, if I divide 2 into that, I'll have a 16 down there. So up top I have 31 times the square root of 63 all over. I'm left with 16 times 32 in the bottom. That's going to give me 512. So this would be my simplified answer. Alright, goodbye.